Hi, so we will discuss about divergence. In the last lectures, we have discussed about some vector calculus parts. Also, we discussed in the earlier lectures about the gradient. Okay. Now I will talk about the divergence, and most importantly, we will look at the geometrical intuition of the divergence. Mathematically, it is very easy. The expression is written here. So, when we define the divergence mathematically, so this is the divergence. When you take the dot product of the delta operator with any vector function, okay, so when you are writing del dot b, this is our simply the operator which we have also discussed in the last lecture when we were discussing about the gradient. So this is just a operator. Now when this operator act upon a vector function, okay, now let us say this vector function is given by this Vx x cap, Vy y cap, and Vz z cap. Vx, Vy, and Vz are simply x by z component. Okay, when you take the dot product of these, or I would say when you apply this operator on a vector function, then we call this operation as divergence. Okay, divergence. Now this is fine. Mathematically, you can take the dot product of any vector function, okay, and in the result what you will get this as a scalar number. Yes, so in the gradient we saw we are operating upon a scalar function and we are getting in the result as a vector, but now it is kind of reverse situation. We are taking or we are operating on the vector function v, and the result which we are getting after the dot product is the scalar number. Okay, because the dot product of x cap and x cap would be 1, similarly y cap dot of y cap would be 1, and z cap dot z cap would be 1, and you will simply will be getting this expression. Okay, that is fine. Now let's look at the geometrical intuition, okay, which is I think very most important to understand, because from the mathematical equation it is little bit kind of hard to get the intuition. Okay, so let's talk about the intuition. So let's say we have some vector function b vector as 1 by 2 x I cap plus, and let's say for sake of the simplicity we do not have any x y component and the z component. Okay, so we are having simply 0 z j cap plus 0 k cap. Okay, so when I am saying I cap, j cap, k cap, these are same as the x cap, y cap, and z cap. Okay, these are the same unit vectors. So now let's first define, or let's first calculate the divergence mathematically, then we will get the intuition behind it. Okay, so when you calculate the del dot b, which is what we call divergence, then you will simply be differentiating partially with respect to x of this x component of this vector function, yes, plus there is no y and z component, so this would be 0, yes, and when you solve this you will be getting divergence as 1 by 2, yes, and this is our positive number. Yes, so when we are calculating the divergence of this vector field, okay, let's draw this vector field. So at x is equal to 1, we will be getting 1 by 2 I cap, yes, so at x is equal to 1, at x is equal to 1, this is our x direction, this is our y direction. So at x is equal to 1, we will be getting 1 by 2 I cap. I cap means simply in the direction of x direction, yes, and if you take, let's say, another point x is equal to 2, then you will be finding 1 I cap, yes, so it will be with larger length, and similarly at higher x values you will be simply getting much higher length. Okay, and if you go into the y direction, and if you, so as the vector field is not dependent on the y component, so you will be getting the same vector field when you will go into the direction of y. Yes, so length would be the same because it is not depending on the y. So it is only depending on the x. So when the x is constant, so you will be getting this. So here also you will be getting this vector at x is equal to 2. Similarly here we will be having this, like this. So this is what we call vector field. Okay, when you draw all vectors in the xy plane for the each point, then this is simply the vector field for this vector function which is given. Okay, so now all the vectors are pointing in the I cap direction, as we could simply guess with this expression of vector. So we do not have any contribution towards the y and z, so we will be having the vector field which is pointing towards the I cap direction. Okay, that is fine. Now let's take any point in this vector field. Okay, let's take this point in this vector field and just circle around this point. You can make any small circle or big circle, it doesn't matter. Just for the sake of simplicity or the discussion, I am making a little big circle. Okay, now let's say this is our this vector is simply v vector is simply the velocity of particles of any liquid. Okay, so now if this each vector is showing the velocity, then if you look at this point, or the circle, the particles are coming through the left boundary with less velocity. Yes, and the particles are going outside with larger velocity. Yes, now when the particles are coming with less velocity, that means the number of particles which are coming through this left boundary or the inside this circle are less compared to the particles which are going outside. Yes, so if you take the net effect, net effect of the particles, you can say this point is behaving like source of the particles. Yes, so the particles are emerging from this point. You can say that if you look at the net effect, because the less number of particles are coming in and the large number of the particles are going out, that means this point is creating, or this point is behaving like a source of the particles. So this point is generating some particles, it looks like. Yes, if you take any point in this plane and you circle around, if you see the less number of particles will be coming in, because if this is the velocity, that means this is the less velocity, that means the less number of particles will be going inside and large number of particles will be going outside. Yes. So each point in this vector field would behave as the source of the particles. And now the positive divergence, the meaning of the positive divergence comes into picture. So when we are having the positive divergence, then it simply means that each point in the vector field of that vector function is simply behaving like a source of that particles or the source of the vector. Yes, so okay, that is fine. So it's like the points are spreading out at each point. You take any point, okay, so it looks like the vector is spreading out from this point. So that is the meaning of positive divergence, because particles or the vector fields, vector points are diverging out. Okay, now let's talk about the reverse situation. Okay, just take the reverse situation. Let's say our vector function is minus 1 by 2 x I cap. Okay, now if you draw the vector field for this vector function, then simply we would be having the vectors in the reverse direction. Yes, so this would be vector field at x is equal to 1, and now take x is equal to 2, then we would be having simply the, so when I'm talking about x is equal to 1, then it means b vector is equal to minus 1 by 2 I cap. If this is the velocity, that simply means minus 1 by 2 meter per second, okay, kind of that. So now if you take any point in this vector field and circle around, then you can see the particles which are coming inside the circles are having the large velocity. That means more number of the particles would be coming inside that circle compared to the particles which are going outside, which are having the less velocity. That means this point now is behaving as a sink. Yes, it looks like the velocity particles are going in this. Yes, now I have made these from other different direction. This is not true. This is not true, because here the vector is pointing in the only minus x vector direction. Yes, so that is simply means the more number of particles are coming from the right side and less number of particles are going less into the left side. That means this point is like a sink, and that is the meaning. If you take the divergence del dot b here, then you will be getting simply minus 1 by 2, and that is negative number. Yes, that is the negative number. So that is the meaning of the negative divergence. Yes, so negative divergence means particles are sinking in at each point of the vector field, and positive divergence means the particles are spreading out from each point in the vector field. Now if you look at the examples which I have taken from the different books, so if you take the first example, now if I ask you find the divergence is positive or negative for this vector field, okay, this is the vector field for some any, let's say for any vector function. Now you can just look this vector field and you can intuitively say that if you take any point in this vector field, now the length or the magnitude of the vector, and let's say this is the velocity, that means the points which are going outside this point, this circle, are having the larger velocity, and the points which are coming inside are having the less velocity. That means each point is behaving as the source of that particles. So here the divergence would be positive. Now just look at this B option. If you take, now just look at the length of these vectors. These are the same. These are the same. So if you are going in this direction or in any other direction, the length of these vectors are the same. Yes. So if you take any point and you circle around, then you will find that same number of particles are going in compared to the particles which are going outside, because the velocity is same. That means with the same velocity particles are coming in, and with the same velocity particles are going outside. That means the same number of particles are coming in as the particles which are going outside. So here the divergence would be 0. Yes, and you can be asked like in the terms of divergence free. We sometimes call it in the gate exams divergence free, okay, because the divergence is 0. If you look at this third diagram, you will find again the divergence is positive, because the length of the vectors is increasing. That means if you take any point in this vector field, it looks like the particles are spreading out or the diverging, okay, from this point. Okay, so that is the meaning of positive divergence, negative divergence, divergence is equal to 0, or what is. So This is all about the divergence. Okay, thank you.